Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, find the highest number. So we'll be given an integer array. We need to find the highest element from that array. The array can either be strictly increasing or strictly increasing and then decreasing. So what the problem is trying to say is we'll be given an array and it can be either strictly increasing like this, right? 1, 2, 3, 4, 5, and 6. So this is strictly increasing, right? Sorted in ascending order. Or it can be strictly increasing, right? So here it is increasing till this point, right? And then strictly decreasing. It is decreasing from here, right? So these are the two cases. And what we're going to do is we're going to find the highest element from the given array. Okay. So this is the array and these are the indices of the elements, right? Okay. Now, also the time complexity to solve this problem is O of log n and space complexity is O of 1. Okay. So how can we solve this problem? So one solution can be, for example, what we can do is we can simply iterate through the array, right? I equal to 0 to n. Okay. And what we'll have is, we'll have one max variable, okay, which will initialize with int min. Okay. And what we'll simply do here is we'll check if a of I is greater than max, right? We'll assign max with a of I. Okay. And we'll simply return at the end max. Okay. So this will ensure that we return the maximum element. Okay. But what is the time complexity here? It is O of n. Okay. Which is greater than O of log n. Okay. So we want to optimize the solution. Okay. So how can we solve this problem in optimized way? Okay, so we are getting some hints here. One is the array is like it is sorted, right? So even if it is right, it is strictly increasing and strictly decreasing, right? So it is still sorted first in ascending and then in descending order, right? And we are also given that the other hint is that it is of log n. So what it is hinting at? So it is hinting at binary search. Okay, so how can we leverage binary search? Let's see. Okay, so we'll have one L pointer and another will be R pointer. Okay, so what we'll do is let's see how can we, let me also write the pseudo code L less than R. Okay. And what we'll do, we'll calculate mid. What is mid? Mid equal to L plus R by 2. Okay. So what will be mid in this case? Mid equal to L is what? 0 plus R is what? Pointing at 10, right? Location 10. So it will be 5. So what it will be pointing at? It will be mid will be pointing at 6, right? At location at element 6. Okay. But at position 5. Okay. So now what we'll do? We'll have a check over here. If A of mid is greater than A of mid plus 1. Sorry. A of mid plus 1. Then what? For example, right? Where is mid? Mid is pointing here, right? And what is mid plus 1? Mid plus 1 is this. So yes, it is greater than, right? But we cannot say that this is the highest element, right? Because we still have 7 here, right? So the possibility. So even if A of mid is greater than A of mid plus 1, that does not mean that A of mid is the highest element. The possibility is that the highest element can still be there on the left side. On the left side. So what we'll do is we will assign mid to R. Okay. That is, we are saying is, what we are saying is R was here, right? So we will point R over here now. Okay. Over here. So because the highest element can still be on the left side, right? So L is here, R will be here, right? So the highest element can still be in this range, okay, in this range, right? In this range. So we are also not excluding 6 because 6 can also be the highest. Okay, 6 can also be the highest. There is a possibility. Okay, so we'll simply say R equal to mid. Okay, so what we'll do, for example, now we have R over here, right? And L over here. So this is a range. So now we'll calculate mid again. Okay, so what will the mid now? Mid equal to 0 plus position 5, right? 5 by 2. Okay, so it will give us what? It will give us 2, right? 2.5, but 2, right? Okay, now mid will point here. Mid will point here, right? So again, we'll do a check. If mid is greater than mid plus 1, right? It is not the case. So mid is smaller than mid plus 1. So in this case, what we are simply going to do is simply going to assign or initialize L equal to mid plus 1. Why mid plus 1? Because see, mid is greater than mid is smaller than mid plus 1. So there is no chance for 5 to be greater, right? The greatest element, right? So we will shorten the range here. So we'll point L here now. Okay, we'll point L here. Okay. Okay. So what is the range now? L is here. Let me, yeah. So L is now here, right? L is here. So our range is this much, right? So again, what we'll do? We'll calculate mid again, right? So what will mid be? 6. This, what is the position? 3. 3 plus 5. L is 3 and R is at position 5, right? So we'll simply do 4. Mid will point at 4 now. Okay, mid will point at 4. So Mid is this now. Mid is this, right? Mid is this. So yeah, so A of mid, that is A of mid is greater than A of mid plus 1. Yeah, this is a true case. So simply we are going to again initialize R with mid, right? So what is mid? Mid is this only. So R will be here. Mid is this position. So R is going to be here, right? Okay. And where is L? L is here. So again, because so this is still, because what we'll do, the possibility is there that the higher element can still be on the left side. So we'll keep on going. We'll keep on going until L is less than R. So okay. So let me simplify again. So here, right? 6 and 7. 6 and 7. 6 and 7. These are the elements. And for the position 3 and 4. Okay. And L is pointing here and R is pointing here. Right? So again we'll do L plus R. 3 plus 4 by 2. So mid is what? 7 divided by 2, that is 3. Right. So mid will point at 3. Again, mid will point at 3 now. Okay. So here we'll check. If A of mid, right? A of mid is greater than A of mid 1. No, this is not the case. So simply what we are going to do, L equal to mid plus 1. So L will also point at here. L is going to point here. Okay. So again, what we'll do, mid equal to, now L and R both are pointing at same position, 4 plus 4, right? 4 plus 4 divided by 2, which is 4 again, right? Which is 4 again. So here we are going to check A of mid greater than A of mid plus 1, right? So mid is here. And what is the next element? Next element is what? 6 again, right? Fifth position. Okay. So yes, it is greater, right? It is greater, right? Yeah. Yeah. No, so sorry, my bad. So now earlier L and R were pointing at same position, right? L and R were pointing at same position. So when we go here again, so this condition will fail because L is not less than R. It is equal to R. Okay, it is equal to R. So we'll come out and we'll simply return A of R or A of L for that matter. We'll simply return A of L. Okay. Okay. So this will be the solution. I hope you've got the intuition. I think it will be more clear to you when I implement the code. So before going to the code, I would request you to subscribe to my channel. Thank you so much. So let me show you the Java code first. Okay. So let's have two variables, L equal to 0, R equal to A dot size minus 1. While L less than R, let's have mid L plus R by 2. Okay. Now, what we'll check if A dot get. So I'll show you C++ code later on. First, I'm showing Java code. Okay. A plus M, right? If it is greater than A dot get M plus 1. Plus 1. If this is the case, then what we want to do? We want to initialize R with mid, right? We want to initialize R with mid, else L equal to mid plus 1. That's what we saw, right? L equal to mid plus 1. Okay. So yes, so finally, when we'll get our answer? When we'll get an answer? When it is this, when this condition fails. That is L less than, when L either becomes equal to R or it becomes greater than R. Okay. So we'll simply return either A of L or A of R. Does not matter. Because both will point at same location at the end. It's taking longer time. Let me submit it. Yes, the test cases are passed. I hope you got the solution. Thanks for watching. Please subscribe to my channel. Let's quickly see the C++ code as well. Okay, so here again, it's like, it's the same. Nothing there to explain anything else. Say L and R. Oh, still, yes. Yeah. So same, almost same code. Not almost, it's completely same code. Okay. So yeah, this was the solution. Thanks for watching. I would request you to subscribe to my channel. Have a happy, healthy, and a great day. Thank you so much.